okay, but more importantly, came up with what the standard deviation was. I didn't bring the right stuff. Do you still have the data in your calculator?
Yeah.
Yeah.
Could you just go ahead and do all this? You shouldn't need your iPad right now. So close it. Anybody who got this right hand, I'll play with it.
I have the data.
Okay, what's
I got
this?
the data.
1.408.
Okay, and n was 6? Okay, and so. They wanted to do a test to determine if they could advertise that it gets 30 miles per gallon, and this was the resulting fuel efficiencies. Is it sensitive enough to detect if the actual fuel efficiency is 28 miles per gallon? So everybody knew that the null hypothesis was going to be mu equals 30 to start with, the original one, right? And the alternative would have been that mu was less than 30. Okay? And the null hypothesis, which is what we always drew when we were talking about power, we did the null first. The null hypothesis would have been mu is 30, and the standard deviation, which would, in this case would have been the standard error, right? Not standard deviation, would have been 1.4081 over the square root of 6, correct?
Yes.
Okay. This is where I think some of you got mixed up. If you had checked conditions with this, you would have realized that the original test, I know you didn't have to go and do the original test, I wasn't grading you on that, but this was a t-test for means, not a z-test, correct?
Yes.
Okay, a t-test for means. All right, now, and since it was a one-sided test on the original thing, here's where if you set alpha at 5%, here's where the 5% would have been, correct?
Yes.
Now, does everybody agree on the original test that from here to the left would have been when you rejected it, and from here to the right you would have failed to reject? When we were talking about power then, we wanted to figure out what is this cutoff value, right? What was the cutoff value that you would give me if it's the bottom 5%? How many of you gave me negative 1.645, or gave me negative 1.96, or gave me negative 2? How many of you used one of those three choices? What's wrong with those choices?
Those are z values?
Those are z values, right?
Yes.
So what I really needed was the t asterisk, okay? And so that would have been for 5 degrees of freedom, because you'll know if you got, does that make sense? Because that feels, oh shit, I feel so stupid, right? Why do you have to check conditions when you're actually asked to do a hypothesis test? Check the conditions and then name the test.
So you don't mess it
It's
up.
so I can grade you and take points off, okay? But really, if you had done that with this, you would have said, oh, it's a t-test. The whole thing is a t-test. No place in here do we have sigma, okay? So for 5 degrees of freedom for the bottom 5%, it would have been, let me tell you, negative 2.015.
Why is it negative 2.015? What confidence level?
Negative 2.015. Well, depending on what you set alpha at.
I set alpha at 5%, but I think I got a different t value for the first one.
I look at the upper tail probability at 5%.
Yeah. 5%, and then I went to
5.
and then 2.0. Oh, I went to 2.57 actually because I did 95%.
Yeah.
Okay.
It's not a confidence interval.
Okay, that's right.
It's a one-sided, okay? But you still, there were other, I think you made a mistake past that, and that's what, I want everybody on board, like, with the logic, okay? So, should it come up with a T cutoff score? I used a Z. If that wasn't your only problem, I mean, yes.
My problem was I set the alternative as not equal to 30. So on the t table, I was unable to find 0.025 on the, what would be 97.5? Or what would it be?
95%.
It would be the same. because you'd only have .025 on both sides.
I know, it would have been 2.571 SATs.
Okay.
It's, do you want a T-table to be looking at while we're talking about this?
Yes, ma'am.
Look, I honestly, because I'm not gonna give you an example that's exactly like the other example, and it never occurred to me that the fact that on the worksheet or whatever you were talking about before, that had sigma was given versus not being given, to me, that seemed like that wasn't like I was trying to catch you on that, it's just that doesn't it make more sense that sigma wouldn't be given,
Yeah.
and it would be a T-test? As I say, there's another problem we've got, what?
So I know that you go to the Z table and.
I'm not using the Z table.
I meant T table. And you said alpha at .05, what percent do you look at?
Can I just wait until I give you these? Because I think if I talk while you're looking at it, how many what's a T-score? How many standard deviations it is away? Negative 0.015? Okay? Now, does everybody understand why you're even interested in that? No? You don't understand why you're interested in it? Because you shook your head no.
Thought I wasn't talking about that.
What?
I was talking about something else.
Does everybody understand why you're interested in the cutoff T-score?
Yes.
Because if you have a T-score of anything less, further away than that, then you're going to be rejecting, and here you're failing to reject. Do you also then understand that what you're interested in, that this means nothing to you, right? I don't care what the sample is. I want to know, I mean, I use it in a formula. If this T cutoff is negative 2.015, what X bar does that equate to? That's what I'm interested in, right? Yes?
Yes.
Am I interested in what my particular sample gave me? I'm really not. So I'd say that negative 2.015 equals X bar minus, well, what's mu? It's 30, because again, I'm talking my original thing, over the standard deviation, which is 1.0481 over the square root of 6. And I come up with an X bar value for this, correct? Which is going to be my X bar cutoff. Tell me what that turns out to be, please.
28.8417.
28.8417. What that says is, if I have a sample of 6 cars, if their average fuel efficiency is less than 28.8417 miles per gallon, I am rejecting and saying, I'm rejecting the null hypothesis. It's not getting the mileage it claimed, right? And if it gets any mileage above 28.84, I'm going to fail to reject. Notice my sample mean didn't come into this at all, right? I'm looking for cutoff values. I had to go through this before I can attack power.
What's the purpose of giving us like the sample mean?
Because you had to come up with this.
Okay, so
I didn't give it to you, I had to give you the data, because otherwise you'd have no idea of S.
okay.
Again, it might appear as though, oh, so you're just giving us extra stuff to screw us up, but that wasn't what the reason for it, okay? When you had your sample, the other problem you were talking about, when I gave you sigma, and the only difference is that you had a cutoff z-score and figured out what the cutoff x bar value was. Okay. You had the data also, you never used this x bar. Okay? I didn't ask you to do this hypothesis test. Okay? Now, so what you're really saying is at 28.8417 and above, I'm going to fail to reject, and anything beneath that, I'm going to reject. Right? Now I can test power. So, my alternative that I'm testing against is 28. Someplace on this side of it is that X bar cutoff, which is 28.8417. It's got the same standard error or standard deviation. Where's power going to be? To the left or to the right?
To the right.
To the left, because this is, you said it's rejecting over here, and this, I would want it to reject, okay?
Yes.
there were a couple, can you see where you made a lot of people used a z-score. But then on top of it, when they were trying to calculate power, used this value instead of the cutoff value. And that came from the test and anything, right? And so you came up with power of almost 100%. Okay?
Yeah.
Okay? So, if I didn't give you the data and asked you a question about power,